This is section 5.3, and we're going to talk about the definite integral. We've done some integration where we had the integral rules, and we had to have a constant added at the end. So it was always the integral equals this function plus c. And now we're going to be evaluating definite integrals, which means we have limits of integration. So when you see something like this, you have the integral from a to b, lower is a, of f of x, that function is the integrand, dx. And when you find the value of that, you have evaluated the integral. You will get a number. So that's the difference. We do have some rules for using definite integrals, and you could go over that. And then we also have these two items that will begin to be important. Area under a curve. If y equals f of x is non-negative and integrable over a closed interval, then the area under that curve, y equals f of x over a to b, is the integral. So it's just saying if you need the area of something, you can take the integral from a to b of an interval and find the area. If you want the average value on a to b, then you do that same integral, but on the outside you multiply it by 1 over b minus a. So those formulas will be important at some point. Let's go look at the problems that we have here. So we start out a little slow here. Express the limit of the sum of, and we have our c 5k delta x sub k, p is a partition from 4 to 11 as a definite integral. So what we glean from that is we are going the integral from 4 to 11, there's our interval, and this is x to the fifth dx. The xk here, the delta xk, that's dx. And then our function here is c to the fifth, that's going to be x to the fifth. So that's how you'll fill in that. We're going to do the same thing here. Now we have an interval, from 2 to 6. So that's the integral from 2 to 6. 1/2 x, this is x, this c sub k is your x, and the delta x sub k is your dx, and that's what we're looking for. So 1 over 2x dx is out to the side, and the integral is from 2 to 6. I think we're omitting that one in the homework, but if you do have one, then we've gone over it. Number 2 that I think is like your homework, we have the same idea. Here is an interval from negative pi over 5 to pi over 7. So that one's going down there. Pi over 7 is your upper limit, and the function is tan x dx. So we're just taking the real math language and putting it into this integral sign. The functions f and g are integrable, and you have 3 things here. Find the values of the following definite integrals. All right, now I would lead us back to the rules that I said you might want to look at. Let's go back here and look at these. So the one that it starts out with, if we have the 0 width interval, so if you're going from a to a, well, you haven't gone anywhere, and so that's going to equal to 0. So let's go back to the problem. The integral from 4 to 4 of f of x dx, that's going to be 0. From g of x from 7 to 2, and g of x is over here, and g of x is equal to 5. So what are we going to do? So as we look here, this that we're given is from 2 to 7. This one says from 7 to 2. And so we were equal to 5 here. Let's go look at our lecture notes. And the rule that if we have a to, let's see, here it is, order of integration. From b to a is equal to negative of a to b. So you're going to get the same value, but it's going to be negative. So instead of a positive 5, we would have a negative 5. All right, from 7 to 2 of g of x is 5. I'm sorry, I just did that one. From 2 to 7 of 9 g of x d of x. Well, we know this is regular. 2 to 7 of g of x is equal to 5, so we're just going to multiply the 9 by 5 and get 45. For the integral of 4 to 7 of f of x, well, we have a 2 to 4 of f of x and a 2 to 7 of f of x. So we have to do some stuff. Okay, so I've added this additivity rule that was back in our lecture notes. I believe it was like number 5. So I've added that here, and we can use it. It says if you have from a to b of f of x plus b to c of f of x, that's equal to from a to c. We don't have that exactly because we have 4 to 7, so we can do 2 to 7, and then instead of plus, because this one is not 4 to 2, we can do a minus this one, and then that rule will still hold, because remember, if it's different limits of integration, that rule says you just make it negative. So we're going to have from 2 to 7 minus from 2 to 4. And so that we have 8 minus a negative 8, and we get 16. So we're using one of those rules. We just had to adapt it a little bit. All right, from 2 to 7 of g of x minus f of x. Well, g of x is 5. F of x is 8. We can say 5 minus 8 is negative 3. In this one, 2 to 7 of 8 g of x minus f of x. So 8 times 5 is 40, minus 8 is 32. So that's what you're doing there. All right, let's look at what should be number 4. All right, on number 4, we are given from the integral to 6 to 7, f of x dx equals 5. So if we have f of u du, we can use the same rule, and that's going to equal 5. When we have integral from 6 to 7 of square root of 7, f of z dz, we're just going to multiply the square root of 7 times the 5. So the variables are changing, but the integration limits are okay, so we're fine. From 7 to 6, now what happened? We changed the order of this, so it's going to give us a negative. Even though it's f of t dt, it's going to be a negative 5. From 6 to 7 of negative f of x dx is also going to be a negative 5 because it's put the negative in there. So that is all that happens in number 4. Number 5, this one is omitted. Number 5, pay close attention to this because people miss this on the test often. If I give them this, graph the integrand and use area to evaluate the definite integral. Do not want you to do integration, want you to figure it out by using the geometry of that. So if we graph the integrand, that's x plus 6. So here is that line, x plus 6. And we are supposed to evaluate it from negative 4 to 6. So I did that, and then this doesn't hit the x-axis, so there's a difference here. Well, what is f of negative 4? If I put negative 4 in for x, I get 2. So this height must be 2. If I put in 6, I get 12. So now I have a trapezoid with a length of 10. Right here's 10. This is 2. This is 12. The area of a trapezoid is 1/2 the sum of the bases times the height. So you have to think of this as a trapezoid turned sideways. So the base here this is the big base, this is the little base, this is the height. So 1/2 of 12 plus 2, so this is 12 plus 2, and then times 10, which is the height, and you get 70. There should be no calculus going on here. we're taking this out of the integral and using geometry to solve it. So if you have one like that on the test, this is the work that would need to be shown, something like this. All right, number 6, graph this integrand and use areas. So if you graph the square root of 100 minus x squared, you get this. Let's get our calculator just to make sure. Just a minute, let me grab a calculator. Okay, so I have, let me move that out of the way. I have put in square root of 100 minus x squared, and I hit graph, and we do get something like this. All right, and so we know that, so use your calculator to graph that if that helps you. And then it says the integral is from negative 10 to 10, so I know I'm at negative 10 and 10. That means my radius here is 10 if this were a circle. All right, so is this area half of a circle? So 1/2 pi r squared, 1/2 pi times 10, my radius is 10, squared. So I get 50 pi. Exact answer using pi as needed, so this would be your answer. Again, do not do any calculus. Use the fact that the integral limits show you where you're going here, and this is the function. So use that. We're not doing one like number 9. We'll just do those 2. So number 7, now we'll get into actually doing our integration. Evaluating the integral from 3 to square root of 14 of x dx. So the first thing you do is find the integration. So it's x is our function. We raise that to x squared and divide by 2. Then we evaluate. I like to write it as x squared over 2, and I put a bracket here with the lower limit and the upper limit. To evaluate, you plug in the upper one, so square root of 14 squared over 2. You subtract the lower one plugged in, 3 squared over 2. So this becomes 14 over 2, which is 7. This is 9 over 2, and so you get 5 halves. If you changed that to 14 halves, you would subtract, you'd get 5 halves, because it does want a simplified fraction or a whole number. It doesn't want a decimal. Number 8, from pi to 4 pi of theta d theta. So the integral of theta is theta squared over 2. We'll evaluate it from pi to 4 pi. So if I plug in 4 pi squared over 2 minus pi squared over 2. This is 16 pi squared minus pi squared. That gives me 15 pi squared over 2. You're supposed to leave pi in the answer, and that should be your answer. Number 9, integral from 0 to 9 halves of t squared dt. Well, the integral of t squared is t to the third, divide by that 3. All right, so I'm evaluating here. Plug in 9 halves for t, so 9 halves cubed over 3 minus, in this instance, 0 just stays 0. Now there will be times where you plug in 0 and it doesn't just eliminate it, so you don't just assume that. But it does here. And so when you cube this, you'll end up getting 243 over 8. Let me see if I get my calculator up. Okay, so this is showing you how you can do this on the calculator and help yourself. So 9 divided by 2 cubed, decimal, you get 91.125. Then divide that by 3, and you get 30.375. If I turn that back into a fraction using math, the math button, and fraction, you get 243 over 8, which is what you should get. So that'll take care of number 9. Number 10, the integral from 6 to 3 of 4 dx. Well, the integral of 4 gives you 4x. So 4x evaluated at 3 and 6. That's 4 times 3 minus 4 times 6, and gives you negative 12. Number 11, Use the rules for integration. It's just saying what you're going to do here, but you're evaluating from 0 to 1 of 2x dx. One thing that you can do, you can pull a number that's multiplied here through the integration sign. And so 2 can be on the outside, and you can just use the x to do that at the end. But if we didn't do that, we have 2x squared over 2. The 2's cancel out, and we've got x squared. X squared evaluated at 1 from 0 to 1 is 1 minus 0, which is 1. Number 12, which I believe is our last one. Integral from 12 to 17 of 4t minus 1. If we integrate this, we've got 4t squared over 2 minus t. That becomes 2t squared minus t. We're going to evaluate that from 12 to 17. So that means I'm going to plug in 17. 2 times 17 squared minus 17 minus, evaluated at 12. 2 times 12 squared minus 12. So then you start doing the math, computation, and you end up with 285. So that should get us going on 5.3.